Okay, next up, we're going to talk about analytic geometry. It's one of our more recent topics, so it should be kind of fresh in our mind. And our big ideas are mx plus b. That's called our slope intercept form, and of course, standard form. Okay, let's start off with some quick warm-ups. Slope of a line. We like slope of a line from a graph because all we have to do is count. Just make sure we work left to right. So up 1, 2, 3. And over 1, 2, 3, 4, 5, 6, 7. There's your slope. We can't reduce it, so that's the answer. Just make sure you work left to right. If you have dots instead, we have a formula for dots. Coordinates, we call them. Okay, y is on top, x is on bottom. Difference between any 2 points. So 7 minus, careful there, is a negative sign also. 1 minus 3, that gives us 12 over negative 2, or just negative 6. As usual, try and work ahead. If you can work ahead, then you understand what's going on. And just check back into the video. Okay, graphing lines. So slope-intercept form, A and B are definitely that form. This one's missing the intercept, which means it has an intercept of 0. Initial value, intercept, same thing, right? It starts at 0. It's a negative. We're going to go down 2, down 1, 2, and then over 1, 2, 3, 4, 5. Okay, 2 dots makes a line. You guys should probably use your rulers. There's our first one. Next one's nice. Slope intercept form still. There's our y-intercept. This time we're going to go up 4 and over 1. 1, 2, 3, 4, over 1. Up 1, 2, 3, 4, over 1. Doesn't quite fit the graph, but we can get pretty close. Ooh, that's a little crooked. Yeah, they should be straight lines, as we know. Okay, C has a problem. It's in the wrong order. We can fix that. I can bring the 3x over to the other side. It'll become a negative 3x. And plus 6. That's negative 2y. We want to know what just y is. So we got to divide by negative 2. But whatever we do to one side, we do to the other. And we'll reduce whatever we can. So 2 negatives make a positive. 6 divided by negative 2 is negative 3. 1, 2, 3. So up 1, 2, 3, and over 2. Up 1, 2, 3, and over 2. And the more dots, probably the straighter your line will be. Okay, D is one of our trick ones. That's a horizontal line. And your y value is negative 4, which means it's starting down there, and it stays down there. Your y-intercept is negative 4. No slope at all. The one that's kind of obvious, but totally looks weird, the x equals 3, that's our vertical line. So x is 3 right here, so that's the x-axis. And x is 3 on everywhere on this line, all the way up and all the way down. In graphing is one of our big skills. Definitely going to see that in our exam. Okay, let's do some more fun stuff. For the equation, y equals 1/2 x minus 1. Identify the slope and y-intercept. All right, there's my slope. M equals 1/2. Make sure we use the right symbols. And my y-intercept right beside it, b equals negative 1. Notice there's no x in there, just a number. Then we write the equation in standard form. Okay, our rules for standard form. X has to go first, and it has to be positive. So I'm going to bring the y over there. If we do that, we're going to be left with nothing. We already have the 1/2 x. Plus y becomes a minus y. Minus 1 is still there. That's great. I've got the x first. It's positive. The only unfortunate part is we got this fraction. We can get rid of that by multiplying by the common denominator. 2 times 1, 2 times y, 2 times 1. Still got a fraction, but now that fraction works out quite nicely. There's no more fraction. There's standard form. Yeah, the point on a grid below belongs to a linear relation. So we know it's a straight line. It has negative 3 over 2 as its rate of change, or in other words, the slope. Which of the following points also belongs to this relation? Well, if it was me, I would graph the line. This tells me to go down and right. And we always work to the right if we can. So down 1, 2, 3, and over 2. Now, this time I am going to use a ruler because I definitely want to make a straight line. I'm trying to find more points on the line. Let's grab that ruler for a second here and bring one down. See if we can get to line up on those points there. Well, that's pretty good actually. Look at that. Okay. Pick my line. Which of these points lie on this line? Well, where's 5, 5? 5, 5 would be somewhere, 1, 2, 3, 4, 5, up here. That is definitely not on the line. 1, negative 2. That's not on the line. 1, 5. 1, 1, 2, 3, 4, 5. Pretty close. Maybe it's a crooked line. I'll have to check that one. How do I check it? This was our slope, right? Down 3, right 2. Down 1, 2, 3, and right 2. It turns out that I did draw my line a little crooked because that is down 1, 2, 3, and right 2 to get to a dot I already know. This dot for sure is actually on the line. I drew my line crooked. So that's always helpful to draw more lines. 0, 4, well, 0, 4 is right here. It's definitely not on the line. That line actually should have been tilted a little bit, probably more like that. Right? Just a tiny little bit of tilt. Just messed it up. Okay, what's next? The equation of a line is given by y equals mx plus 9. Oh, good, they give us half the equation. If the point negative 4, 7 is on this line, determine its slope. Well, we can do that. This is an x and a y. We know we can solve for stuff if we know points on the line. Y is 7, m. Usually I give you the x and the b, or so the m and the b. I want you to solve for the b instead of the m. But we can do the exact same thing. What does it mean for brackets? It means they're multiplying. So really that's negative 4m. I'm going to bring the 9 to the other side and subtract it. That's negative 2. I don't want negative 4m though. I want just m. Whatever I do to one side, I do to the other. 2 negatives make a positive, and 2/4 is the same as 1/2. Hey, we just found the slope. Okay, let's write some more stuff about lines. Write the equation of a line that's perpendicular. Ooh, you know what that means? Opposite slope. So here's our slope. What's the perpendicular slope? 2 has to become 1/2. I'm going to flip it over. It was a positive, so now it's a negative. There's a perpendicular slope. And what else did I say? With the same y-intercept as this stuff. Oh, what's hard about that? I can't see the y-intercept right now, but we can fix that pretty quickly. Let's put in the right order. Let's bring the y over here and bring the 6 back. 6 is a minus. The y is a plus now. We'll divide it all by 2 because we want y equals. And equals y is the same as y equals, right? Just read it backwards. 6 divided by 2 is 3. Hey, there's my b. That's my intercept that I need. So what's our equation? Y equals, want the perpendicular slope and the same y-intercept. And gathering information about the equation from other equations. Write the equation of the line with the slope of 3 that passes through the point. Oh, there's our standard equation right there. We knew that was coming somewhere. All right, we always start by filling in what we know. Mx plus b. There's our m. We can solve for b if we know a point. Kind of what we did here, right? We solved for m. Well, this time we're going to solve for b. And y is 4. X is negative 1. Get rid of our brackets. Bring the 3 on over, becomes a plus 3, and b is 7. So our equation is y equals mx plus b. Oh, we got a context question. So it sounds like it's going to look like a linear relation question, but we know it's really just analytic geometry. The SAC sold tickets to the championship football game for a total of $5,792. Students pay $4, non-students pay $8. Total value can be described by this. Okay, so 4 for every X. Well, this must be my students. And 8 for every Y. It must be the non-students. What is the maximum number of students and non-students that could have attended? So really, I'm thinking about the biggest possible X. Well, what happened if no non-students attended? 0 of those. I think this is a tricky way of saying, let's find the intercepts, the baby table method. So if no students attended, there's none of them, 8y, 5792. That means there's none of these. Don't even worry about that. Don't solve that. Solve what's left over. 5792 divided by 8, divided by 8, and y equals, let's figure it out. 5792 divided by 8 is 724. We'll do the exact same thing for this one, except we'll make y be 0. The fact that it's 0 means I can basically ignore it. All I really need to do is solve what's left. Divide by 4, and x is, let's figure it out, 5792 divided by 4 is 1,448. Okay, the maximum number of students, I think students is the x's, right, is 1,448. That's assuming that no non-students attend. And the max of non-students is 724. Again, that's assuming that no students attend. Probably not likely. It's probably some combination of the two, but we don't know what it is. Okay, the graph below represents a relationship between the number of people exiting the gym after an assembly and time. We don't have those this year. Okay, so take a look at this graph here to start. Yeah, at the beginning, at time 0, there was a whole bunch of people in the gym, that many. Don't know how many. There was a bunch. Over time, they started going down. After 2 minutes, it looks like there was 350. After 9 minutes, it kind of looks like there's nobody left. Determine the initial amount of people and the rate of change. So again, it's a context question, but really it's asking for the equation of this line, the slope and the intercept. Can we find those? Well, sure we can, because we actually know 1 nice point, 2 nice points. So our rate or our slope, let's find the difference between any 2 points. It's negative 350 over 7, which is negative 50. Now really, these are people. It's going down, which makes sense, right? Negative means there's X in the gym. And this is what? Minutes? Okay, so we're going out at 50 people a minute. How do we find that initial value? Well, let's go back and solve for it. Do we know any nice points on this graph? Absolutely, we've got 2 of them. Pick one. I'm going to pick 9, 0. I think it's nicest. It's only got 1 number involved. Okay, 50 times 9 is 450. Bring it to the other side, and we get 450. All right, here's our initial value. Initial number of people. And there's our rate. We just called them slope and intercept before, right? They're the same things. Okay, determine the equation of a line that passes through negative 5, 6. That is vertical and horizontal. Wow. If you remember the trick to these, this is actually probably the fastest question. Negative 5, 6 is about there. Yeah, I want a vertical line that goes through here. What's true about vertical lines? They all are the same distance away from here. The x value is always negative 5. That's all you have to write down. Can you guys remember the other one? Y has to be a horizontal line, would be like this, right? What's the Y value going through? Well, it's the same height. It's always at 6. And we like vertical and horizontal line equations. They're actually the fastest things to do. Okay, let's try, I think we got, what, 2 more? 1, 2, yep, 2 more. Okay, a boat is traveling from point C towards point D. So it's down here, and it's going that way. Okay, good job on the arrow there. Which is on the shoreline. The shoreline is represented by the lines through points A and B. So A and B is my shoreline. It says shore. To determine whether the path from C to D is perpendicular to the shore. Okay, well, how do I remember perpendicular? It's all about slope. Now they've given me coordinates, so I could do this. Let's do CD first. C to D. I'm going to do -2 minus -8. So I want this direction. So I have to do 6, take away -3. And that gives me 6 over 9, which reduces to 2/3. We can do the exact same thing for A and B. So pick these two. I'm going to do -5 minus 7. So I'm working in this direction. And 8 minus 0. It's -12 over 8. I reduce this 2. Divide both by 4. That's, oops, not 4. Divide them by 4. 3 and 2. What do we notice about our slopes? They are negative reciprocals. They're upside down from each other, and one's positive, one's negative. So we could say, yes, they are perpendicular. That's our symbol for perpendicular, remember? I suppose a fast way of doing this question, if it was me maybe, I might have just counted on my graph. I have to go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my same thing. Or if you find 2 nice points, like look at these two. Down 1, 2, 3, and over 1, 2. Down 3 over 2. We could have counted. We had a picture. But our formula works just as well. Okay, last one. Determine the point of intersection. Ooh, it's one of our last topics. I don't want to graph these. We know they're not going to be nice to graph because that's 13. It's our big slope. So we learned a trick about figuring out how they are equal to each other by making them equal to each other. That's what a point of intersection means, where they're the same. Let's solve this. 2 comes this way, 4 goes that way. We got 11x, mistakes there, equals 11x is 1. Nice, I got half the point. Take one of the 2 equations. Doesn't matter which one. I'm going to pick the bottom because it's smaller. I know x is 1. It says so right there. I do my math. I've got 9. POI is 1 and 9. Now to check it, I could also use the 1 in the other equation. So just for fun, let's see what happens if we do that. Ooh, we also got 9. I already know it's the right answer. Okay, there's a bunch of things from analytic geometry that we should know. We're going to again try our sheet this afternoon, or the second half of this. I'm going to hand it in to me. We're going to check on how things are going. We're going to go back and review one more topic, the numbers and algebra stuff again, just because it's the longest stuff ago. Throw some more things at you. Hopefully this last one pretty good. If you're stuck though, send me a message or come see me and we'll figure it out.